component of a system. Also, we can just imagine what a food system will include. So it must include many processes, right? So if we have a breakfast in the hotel, we need to have the milk, have coffee, and also vegetables, potatoes, or bread, right? And those food products have very complex upstream processes, such as the distribution, production, and also fitness replication. So those are the processes of food system. And also food system has many drivers. For example, if people get richer and they will have more diverse or more larger amount of food intake every day. And food system is a complex system. So we need to consider the resilience of the food system. So combining those components, we could evaluate or quantify the impacts of food system, and also explore or investigate some sustainable solutions to transform or improve the performance of the system. So based on that, we could say there are qualitative analysis and also quantitative analysis methods. But these two methods are not controversial or conflict. They could be a supplementary method for each other. So here is a one version for the system defined by FAO. We could say for sustainable food system, they could increase better food supply and also increase food security, and they could also a more sustainable food system could also contribute to more decent jobs. For example, farmers will have more decent working conditions so that they would not suffer from the rain or sunburning, and they could use machine. And based on that, they could also increase their secondary income, right? So this is one of the definition of the sustainable food system, and we could say there are many dry or causal loops in this food system. And from my own understanding, I think food system has core processes and also extensive factors, influential factors especially. For example, the core process could may include food production, and after production, the food will distribute to factories or for processing, and also will be delivered to markets for retail, and people will buy those food from markets or grocery stores, and then they will store the food in their fridge or just prepare for consumption. And after that, we some of the leftovers or inedible parts will get recycled or get disposed. So this is a core process of food system. So based on that, the food system have some upstream processes that are usually omitted. For example, during the food production, we need machinery, fertilizer, or facilities that is also the very important production factors for agriculture, right? So those processes are also important. For example, if a farmer buy a truck, so this is a very large facility and cost a lot of energy and materials to get it built. The other part is the social and the environmental factors, which is also intertwined with the core process, especially if we need to understand the food system in a comprehensive way, we need to care about the income of farmers, the tax revenues of the agriculture sector, or consumption phase. And also we need to care about the supply. And for the environmental impacts, we need to care about many environmental impacts, for example, the emissions, the water resource, and also pollutants, and also the biodiversity impacts. And for the social impact, we also need to the health, and also the healthcare, welfare, animal welfare, and also food safety, and many other issues. So this is the the core processes, and also the essential factors related to food system. I think many of each of the process or factors is a very nice topic for us to investigate in details, especially if we focus on a specific region or a specific period of time. Talking about the region, we could say there is not a huge regional difference in food system. For example, if we look at the food system from the production perspective, we could say the production, the agricultural landscape in different regions is quite different. For example, the left figure here is showing the soybean production in United States, which is which is produced in very large scale, so that could enable is intensive use of machinery. In that case, farmers have less workload and also have more decent working conditions, right? And for this is the right figure shows the terrace in southern China. We could say the cropland is highly fragmented, so a machinery is not possible here, and farmers can only manage a small pieces of cropland, and they should climbing ups and downs the hills. So that means the working conditions not that good as the left one, right? So this is a differences in regions, and from the consumption perspective, we could also say there is a huge regional differences. For example, if we do a questionnaire or field survey to ask about people in different regions to name a few of the prioritize the concerns of the food system. People in, like, for example, in East and Southern Africa, they would care about availability of food and also affordability of food, right? For another example is, for example, the Asia and the Pacific, this which is market in blue, and they care more about sustainability and the environment, and also no income below living standards, right? So they have different priorities concerning the food system. And the other one example is the affordability of health diet by food system typology in different regions. We could say in rural regions, about 90% of the people cannot afford healthy diet, right? Because a healthy diet may suggest us to have more vegetable and milk or egg that is more costly than the current diet. So 90% of the people in rural regions cannot afford sustainable diet. Yeah, but for like industrialized countries, like more of the people can afford, and 0% people cannot afford. So this is a regional difference we need to consider about the food system. Okay, so we have a very brief introduction of the definition of the food system and also the regional differences of the system. So we could say the food system has a very obvious criticality. because we need to have a equal development across regions and or populations. Yeah, we need to also improve the well-being for all, not only for industrialized countries or developed countries, right? Because the health and also nutrition status in underdeveloped countries is much lower or much or needs more or requires more attention. And also, food system is also the key pillar for climate and environmental goals. So we could say about 30 years ago, during that time, Chinese people have less access to nutritious food, and health status is quite low. So there is a slogan or somebody can't hear you clearly. Sorry. Yeah, I will talk louder and closer. How about now? Can you hear me now clearly? Is it better? So I will continue talking. So this is like a slogan in China about 30 or 20 years ago, saying a glass of milk can make Chinese people stronger. This is because the unhealthy or lack of nutritious food in China during that time. Yeah. So food system also have many challenges. For example, we are running short for cropland and water resources for agriculture production. And there is many concerns on food safety. For example, there are two there are we want many of us may prefer organic or natural products compared to ultra processed food, right? Yeah. And also there is a double burden nutrition, yeah, which is mentioned before. So I can show you another example for this. So this is a article paper about 10 years ago, trying to review the chemical-free consumer products, meaning that, for example, the food or other products, there is no chemical additive to those products. So you could say this paper have 2 pages, but only the abstract and the rest of the paper is totally blank. So what's the meaning of this? Yeah, that means there's no products which is chemical free, right? So this is one of the challenges of the food system. And there are also opportunities for the system transformation. For example, we have many kinds of technical innovation, and there are many more recommendations or policy implications from research or from regional practices that could be transferred to other or shared to other regional contexts. Yeah, and we have many educational or consumer behavior on consumer behaviors. For example, there are many more people in Europe turned to become a vegetarian to get rid of beef and chicken. In that case, they could both improve their health and also improve to benefit the environmental sustainability by all the kind of methods and how we can analyze or improve our understanding of the system. So I will elaborate a few methods, and then maybe you guys have many more ideas or thoughts about this, and we can have discussed later. Yeah. So here is a in general, by analyzing food system, we could use qualitative or quantitative analysis method. So this is the difference between these two. For example, the focus of quantitative research is to explore ideas and formulate theories or hypotheses. So this is a kind of general concepts of the of our research studying object or food system. Yeah. But for quantitative research, we need to testing or prove or reject the hypothesis. Yeah, and the analysis of quantitative research is to summarizing, to categorizing or interpreting. But for quantitative research, we need to have some math calculations or statistical analysis. And there are also other differences. For example, the impression method, the sample, the samples. Yeah, because for example, the quantitative research need to many respondents, but this is not the case for qualitative research. Yeah, and characterization is also different. For the qualitative research, we only need to understand the context, the complexity, and also subjectivity. But for quantitative research, we need to test, to measure, to uh, to focus on the objectivity. That means for every conclusion we need or have we need to have data support, and not supported from the concept or ideas. Yeah, it should be supported from the data. So those are the differences between qualitative and the quantitative method. Yeah. Uh, Here are more details for these two methods. Especially for the data connection and also for the data analysis. They also have some differences, but this is very similar to the slides just showed you. For example, for quantitative data connection, the data is usually connected from interviews or focus groups through discussions of a group of people, and also from literature review, right? But for quantitative analysis, this data will usually connected from experiments or monitoring or observations. So those are differences. So firstly, I will introduce a few methods of qualitative method, qualitative analysis. The first one is the framework thinking. So from the term, I believe you could have a general idea of what is framework thinking. So here are the definitions. Framework thinking is essentially a problem-solving approach. So it's a problem oriented. We need to solve a problem or answer a question through many procedures or through many data or other or a few analytical method. Yeah. So it is also interactive process. So in this interactive process, we can improve our understanding or deepen our understanding step by step. So this is the definition of framework thinking. So here is a question for framework thinking. So how will you cook a bowl of fried rice in your classroom? So this is a kind of weird question, right? Yeah, but this is the only practice of framework thinking. Yeah. So if you can type or speak, you can just unmute yourself and say how and talk how to cook a bowl of fried rice in your classroom. Or otherwise, you can just type in from the chat box and tell rest of us how will you cook a fried rice in your classroom. So actually here, I also have some, instructions here or primary thinking for this weird question. Yeah. So I didn't say any chat from the chat box. So I will continue. Um, so if we need to cook up our fried rice in our classroom, right? So there is no kitchen in the classroom, right? So we need to connect the facilities, for example, pots, or oven, or spoons or knife, yeah, or anything else. Yeah, that is many kitchen facilities, and that is not uh that we don't have in our classroom. Yeah, yeah, rice cooker. Yeah, good. Yeah, yeah, we need facilities. Yeah. Okay, yeah, rice cooker is the first step to cook rice, and then yeah, we fry the rice in a pot. Yeah. Okay. The next group of materials we need is the ingredients. Yeah. We first of all we need to buy rice from the grocery store, and we also need water. And since we are going to fry the rice, so we need oil and salt, and also additives. For example, we may add some green beans or carrots or onion or anything else in the fried rice, right? Yeah, and we also need fuel or electricity based on what kind of oven or rice cooker we have, right? So this is materials. Yeah, and based on this, we could have some understanding how what framework thinking is about. Yeah, we try to solve this question or answer the question. Yeah, and for a better implementation of cooking fried rice in classroom, um, we could do some experiment because many of us, especially students, have limited experiences in cooking fried rice independently, right? Independently, so we may need some uh, uh, to check the cooking skills from like YouTube or some other social media to say, yeah, how fried rice is cooked. And we may need some experiments, and we also need some teamwork because someone will go to buy the facilities or borrow facilities, or some other ones will, yeah, to connect water, salt, and the rice. Yeah, this is the teamwork, yeah. And after that, after the rice is cooked and or eaten by us, and we then need to clean up the classroom, especially the desk or others, yeah. And especially cooking rice in classroom is not limit, it's not allowed. So we need a guard maybe to watch to take care of the security from the campus or professors from the campus, right? They may, yeah, they may, well, because this is forbidden, right? So this is framework thinking to to solve this weird question. Okay, so this is some explanation. Okay, so get into real research. This is the one paper from my students published this year, investigating the impact of Russia-Ukraine conflict on the food system, global food system. So this is a framework on the food system response to the Russia-Ukraine war. We're trying to look at the three aspects of the food system. One is the shock. So how the war will affect the global food system in what ways, and what are the factors? For example, uh, the duration of the war, or the and also how many countries are involved, and also how many cropland will be abandoned due to the war, and also what will the fertilizer price will go up due to the war and things like that. Yeah, we need to uh, define the shock of the due to the war. Yeah, and then the next step is to focus on the impact. Yeah, especially because many of the cropland is abandoned during the war, so there will be definitely food shortage for a few regions and also for a few food types, especially um, uh, for the food types that is produced in Ukraine and Russia. Yeah, and the other step is to investigate the response from the global food system, especially when we suffering from the food shortage and also the increase of prices price of food and also fertilizer, how the global countries can collaborate to adapt to the food shortage and other impacts. And also those kind of impact, those kind of adaptation could also reduce greenhouse gas emissions and also reshape the food production and also trade network. So this is a framework to solve or answer the question of how the conflict affect global food system. You can have a general idea of how um, the the concept is built up and how the different factors are intertwined or interconnected, and how to combine different parties to answer the overall question. So this is examples of framework thinking. The second analytical method is system thinking. Yeah, I think this is more familiar to most of us. System thinking or systematic thinking is a process of understanding how things influence one another within a whole. So this is kind of different from the framework thinking, because the former one, the framework thinking is trying to solve a problem based on many procedures. Yeah, but for system thinking, we focus on the relationships between different parts or different factors in a system. So system thinking is very significant because it help us to identify the interconnectedness, and also um, it also for system thinking, uh, we will remind ourselves again and again to include as more as include most as most factors as possible, right? To do not limit or omit one hypothesis or one factor. And also it will improve the entire system support and support different systems. So this will systematic thinking will help us to to understand the entire system, not one part of the system. And this one also this system thinking also takes feedback into account. How to implement system thinking? This will start by learning and observing. For example, for system for system thinking for food system, we need to understand what processes they have, what factors they have, and what's the relation between among them, right? So we need to identify and analyze the problem. So we need more, literature review and also discussions from peers, and also consultancy from senior researchers, etc. And there are also many other procedures, for example, shortlist interventions. Yeah, we need to what kind of interventions or factors we have, and what are the most key interventions or factors, and how they interconnect with each other, and apply the solutions to the real practices of industry. For example, we need to, if we want to improve the health status by dietary transition. Uh, we have a few solutions to improve or nudge the dietary transition, and we need to apply the solutions to see what's the feedback from the from the people. And there are views on vegetarian, there are views on meat eater or something else. And based on that, we can continue the improvement processes. So we can go back to the rice cooking in our classroom. So this is the framework thinking results I just explained to you. And also, there are also some discussions from the chat box. And from a systematic review, there are many other factors we need to consider. And also we need to consider the interplay between the factors, right? For example, we need a coordination between facilities and the ingredients. For example, if we can buy some ready cooked rice from grocery stores, then we don't need a rice cooker, right? And if we could buy some, if we can buy some like onion chop or carrot chop, and then we don't need a knife to cut the vegetables. So there's coordination between facilities and ingredients, and also we could to improve the flavor through experiments, and this would also is a causal loop or feedback from different parts of the factors. And we could also improve the cooking skills through with more instruments. And there is also if we have some cooked rice from our classroom, we could ask a few students to taste the cooked rice to say if the flavor is good, or if we need more salt, or if we need less oil or something. And then we could improve the cooking skills and also the cooking procedure. We need comments from the yeah from others. And also how to deal with the leftovers. Right. If we have 20 students in our classroom, we cannot have fried rice, but we can't eat all of them, and there will be leftovers. So how to deal with that? And also, if there is some security concerns, if we cook in our classroom, for example, the electricity or fire or anything else, and could we buy pre-cooked ingredients for heating, or is there any either ways for cooking, or otherwise we can cook on green space instead of in our classrooms. Those are the factors that could be further considered if we consider this question from a systematic review, right? So based on that, we could say in a systematic review, we need to be comprehensive and complex, and be aware of the extensive issues of current cognition. So this so based on that, we could say systematic thinking is interactive, right? So here are examples of the causal loop of diagram of reactive nitrogen, which is also the key pollutant from food system. So we could say there are crop planting, livestock breeding, food consumption, and waste production, and those between those components or factors, there are many other influential factors or drivers for each of the subsystem, and there are also relations between them. For example, there are straw reuse, straw used for livestock breeding, and there is also livestock excreta reused to crop COVID-19, right? So there are many other drivers or influential factors related to those components. So this is an example of the system thinking of the food system, and this framework can be also further improved if we have some discussions with our peers or experts in this field, right? This is another example for the system thinking to be comprehensive and complex. So this is the food system for the system relations, the relations between food system and SDGs. We could say this is a components of producing microbial protein from organic waste streams. We could say if we use microbial protein from organic waste, it will reinforce, which is showing blue, reinforce the recycling of waste. But on the other hand, it will also negatively impact the soybean cake quality. So we could say from each process have some negative or positive relations with other processes. So this is another example from the same paper. We could say if we improve our personal diet, for example, we adopt healthy diet, sustainable diet. So what's the environmental outcome of sustainable diet? We could say the relationship is unclear because in some regions, if we adopt the sustainable diet, the environmental impact will be lower. But in other regions, it could be higher, right? So this relationship is unclear, but we could say there are many other negative and positive relations in personalized nutrition adoption. So this is also an example of system thinking by including as many factors as possible to understand the relationships of the for the system factors or for the system components. So during the framework and the system thinking, there will something or some parts that is unsure or we don't know because not everyone has a very deep or comprehensive understanding of the system. So if we have no idea about the research topic or what we should do, actually, we should, read more literature and do more consulting or discussion from with our colleagues. For example, how to promote dietary transition, especially to promote recommend less beef consumption and more vegetable consumption. From the framework thinking, we need to solve the problem or answer the question. So we could do education from the case. For example, if we have a little sister or little brother from primary school, and the teachers over there may teach the students to eat less beef because this is more sustainable or healthy, and then this little kid will come back to the family and then influence their older brothers and older sisters and also the parents. So this is how education works. And also there are many many other instruments for such as policy, taxation, nudging, or others. But from a systematic thinking, we need to think about the effects of the producers, markets, and or non-use. For example, if if everyone in the world eat less beef, so the beef producers from Brazil or from Argentina, so the producers, farmers over there will have have less income, right? Because less beef will be sold. So this is the effect we need to consider. Yeah, we also need to consider the market response. For example, the grocery stores will prepare more vegetables, but will the shelf will be full of vegetables but less meat, right? So this is some of the external or extensive factors we need to consider from a systematic review. Yeah, but actually all these thinkings are based on literature, expert reviews, roundtable discussion, and field survey. Yeah, so it's not come from yeah, we can also brainstorming it, but actually more of them come from external input. Yeah. So here is a case by to analyze the resilience of food system resilience by using uh, framework thinking and systematic thinking. Food system include growers, processors, processing, and distribution, markets, and consumers. So those components are intertwined, and if we improve the urban agriculture in the food system, and this will have some resilience effects of the food system because the processing will be changed and there is a more local provision, so distribution will be reduced, and there is a more diverse food supply, so the network will be improved, and yeah, and there are many many other impacts if we grow food from the city, and this will ultimately affect the resilience. So from the systematic thinking, we need to also think about what should be further included in resilience, resilience framework. Should we also consider the recovery ability, the ability to refill the shelf, or the ability to shift to another source of the supply? This maybe some other some other factors that could be included in the resilience analysis. So there are also some decision making by using this kind of analysis for the food system, especially if we want to improve the security of food system, what should we do to solve this problem? So from the framework thinking, first we need to do material funnel analysis, for the food system to say how materials are recycled, and what's the possibilities to improve the circularity of this food system, right? And the other one is to because we have many circular alternatives, so we can prioritize some of them, and with this we also we also need to validate with the stakeholders. Yeah, and we also need a literature review to see those secondary alternatives are functioning good enough, and will not have some negative impact on the food system. And the next step is to simulation of the cost benefit scenarios, because we have some recycling activities and what will be the cost of this recycling, and what will be the benefits of this recycling. This is another thing we need to consider if we improve the circularity of the food system. So if we want to enable this circularity of the food system, we could make this food system functioning through these three gears, and these three gears are network collaboration, change of strategy, and also capacity building. So with these collaborations from these three gears, we could improve the circularity of the food system. So those are the examples of the framework thinking and also systematic thinking of food system. With this, we could also by illustrate some of the operational structure of the security food system. For example, we need some coordination team and also environmental agency. So actually there are 5 stakeholders. The rest are the anchor company, service center, and also supply network group. Especially for the anchor company, this is very interesting. For example, if we want to improve the circularity of food system, we could invite some suppliers to supply some straw or animal excreta or others that could be reused in crop production. And we could also invite some experts to assist the workshop that to build up the connection or build up the trust of the stakeholders to make this whole system or this regime function. And we also need some leadership in container production. For example, some of the anchor company could share some of the experiences or some of the knowledge from the experts could be implemented or experimented in the companies or in the farms. So this is also is the extension of the the um, framework thinking in our food system. So the last part will be the quantitative analysis. So I'm asking if you guys want to have a rest, or it's okay for me to continue. Last part, we have discussed some of the examples of how to conducting framework thinking and system thinking to analyze food system. So here, to be continued, we will talk about we will discuss about the methods to quantify the characters or impact of food system, and understand the food system based on sorry, understand the food system based on data supports, not ideas or concepts. So why we need to quantify? Peter Drucker once said that what gets measured gets improved. So this is basic for foundation for us to improve the the system or practice. Yeah. So we need to solve the target problem, unintentionally create other problems. For example, we for example, we promote vegetable consumption, and there will be more vegetable will be produced, and more carbon will be used. So this is other problem caused by one target. And we also needed to be aware of the system boundary. So what should be included and what are not included in the quantification. So here I will introduce 2 methods for quantification. The first one is the material flow analysis, and the other one is the life cycle assessment. So both of these two may be familiar to some of you, but we could discuss uh, further discuss those methods to see how they could be applied in full system analysis. So material flow analysis is a systematic assessment of the flows and stocks of materials within a system defined in a space and time. So this is a quick, generally, uh, analyze the sorry, analyze the flows and the stocks. So the common purpose of material flow analysis is to find some inefficiencies and optimize the conversion processes. For example, in a code system, we could say which process is most inefficient and how to improve it. Yeah, and what's the efficiency of materials. For example, water use efficiency or energy use efficiency, things like that. And we could also anticipate for future definition and also accumulation. For example, from the material analysis, we could we may find that there are too many cause some degradation of soil quality and also cause some water pollution through runoff and leaching, right? So those are the purpose of material analysis, and the other ones include test the performance of indicators such as the efficiency or circularity, and design the design efficient systems. Yeah. So how to improve the performance of the material flows, and also anticipate future emissions or impacts. Yeah, these are the purpose of the material flow analysis. So what are the flows and stocks, which are and also processes, which are the key procedures or components of material flow analysis method? So flows definitely means the mass or materials that is used at a time. And stocks means materials that are remain or storage remain in storage for the study duration. So and also processes transformation, transport or use or reuse of the materials. So materials flows or stocks is defined based on time and region. For example, the building we are living in or classroom we are staying in a short period of time, we could say we could define the building as a stock because the materials is not going anywhere else, or no additional materials added to the building. So we could say the building itself is a kind of stock, but if we put the building in a longer time duration, for example, centuries or tens of centuries, so many buildings will be kind of become the flow from the building materials to building waste, right? So this is we should be aware of the time and the region of the material flows and stocks. So the importance of the stocks and flows, we could say, especially flows and stocks contribute to well-being, to the function of the materials or the products, and to understand the material or resource use efficiencies and also the waste generations. For example, stocks could be used for our for our daily purpose, such as the building or table or chairs. Those are the stocks that are in use and could provide us some functions. So there are ways of defining a system boundary to conduct material flow analysis. We should firstly have the temporal definition of the temporal boundary. So we need to first be clear. We want to for how long we want to conduct the analysis for 1 year or for 1 day or for 1 week. Yeah, and also the spatial boundary and also the activity boundary. What of the processes are included and what are not included, and also the entity. For example, the organizational entity, such as the the companies or farms or restaurants or others. Yeah. So those are the 4 ways of system boundary definition. And since material flow analysis looks at the materials, goods, and substances, so we could basically understand what the physical world, through the material flow analysis. For example, we could look at what we have in the classroom. There are desk names, blackboards, and also computers or any others. So those are the materials, goods, and that serves our daily life. So we could take another example to see how material flow analysis is conducted. So assume Masha, Stuart and John share a fridge, and they was both every one of them buy some food from the grocery stores, and they eat some of them, and then there will be leftovers in the fridge each week. So we could say the system boundary for this material analysis is like the fridge or the three colleagues, Masha, Start, and John, and also the temporal boundary is 1 week, and also the entities are food and also consumers and also shelf in the fridge. So we could do some calculations to see how much leftovers will be there during 4 weeks if the board and also the eaten will keep the same, right? So for example, for based on that assumption, we could say for the first week there will be edible stocks or leftovers for about 0.9 kilograms, and after 2 weeks there will be 1.7 kilograms, and after 4 weeks there will be 3.1 kilograms of leftovers. Yeah, during the 4 weeks, and we could get to know how much you used, how much is left, and how much is on shelf through the material flow analysis. So the key indicators will be inflow, outflow, and stock. Another example is for the material flow analysis is firstly we should combine the quantitative overview of the process of diagram. For example, if we produce papers, we need wood to produce pulp, and pulp to produce papers or for direct sales. And there are many other materials that could be produced papers. For example, the non-fibrous could be used to produce paper. The waste paper could also be reproduced to produce new paper. I just said this is a qualitative diagram for paper production, and based on the qualitative diagram, we could then quantify or connect data to say what's the material amount, how much material flows were stocked in those processes. And for example, wood will supply 7.1 million tons of pulp, and also 2.9 million tons of wood products, and there are also many other suppliers and receivers during the material flow analysis. And if we have the data organized like this, and we could just copy and paste those data to schematics .com for visualization. And also the visualization also could be done through, R programming or others. Yeah, we could say how much wood is used for pump and for waste and also for wood products, and those are numbers. And we could also further analyze efficiency or security or other indicators, right? So here is indicators based on MFA. We need the quantity, the input, throughput, and the output. So actually, we could say from the first step to the second step, there will be some, processing or waste, and then followed to the next step. So this is general um, general diagram of a material flow analysis. So we could define two key indicators of the material flow analysis. So first one is they are efficiency, and the secondary, which I mentioned for several times before, right? And those definition could be easily understood through these two simple quantification methods. So if we want to evaluate the indicators of this material flows. For example, the efficiency of primary processing efficiency. So you could imagine what will be the equation, right? And if we want to evaluate the recycled input rate, and you could also imagine, which will be the method of quantification. Yeah. So here is the answer. Here, if for example, if we want to, evaluate the recycled input rate, so this would be in like D two. Yeah, this is the recycled rate, and then divided by the total input, and also the total output. Yeah, so those could be the recycle rate. Yeah. And the efficiency and the security are interrelated. For example, if we improve the efficiency, and the security will be also improved. So if we want to account the framework, we need to know how much is inputted into the the processing system, especially those inputs may come from imports or from domestic extraction, and the output could be export to other regions or emissions to the emissions from the production site, and also there will be some social economic stocks during the system. So this is a full accounting framework which shows more details of this idea, but actually generates the same. So here is the example showing the food waste in China, which I was co-authored in that paper a few years ago. We could say there we classified the food into several categories, and each category we quantify the amount of production, and then this amount of production will goes to for feed, or goes to industrial use, or goes to seed, and then the rest will goes to post harvest and storage for human consumption. Yeah, during the processing there will be some waste that goes to for the waste and loss, and then after processing, the food distribution and the retailing, there will be also some waste, and then during the consumption, I could say there is also some waste that goes to this part. And for all the other food categories, we did the same thing to say how much food is wasted. Yeah, we could say the the white side of the arrows shows the amount of the wasted food. You could say this is a very remarkable or taking about 28%, 28%. This is nearly 30%, which could, supply the food for millions or billions of people. So here is the detailed information on the food loss and waste through the material flow analysis. We could say how much food is wasted in different stages of the food system, from production to consumption. Actually, the post-harvest handling and storage takes about 45% of the total food loss and waste. And here is food loss and waste divided by food categories. We could say, fruits and vegetables takes about more than 60% of the total food waste. Yeah, this is a lot. Yeah, and then we also quantify the total ratio of the food and loss waste. For example, fruit and vegetables takes the majority of the food loss and waste, but actually you could say the ratio it's about 50%. That means half of the fruit and vegetables are wasted or lost during the supplying and consumption stages. So this is quite a lot. Yeah, and this is also some the conclusions are driven by data. So this is a typical example of quantitative analysis. Okay, so if we want to know some of the emissions during the food production, for example, the methane emission or nitrate oxide emission, or ammonia emission from the crop livestock or agriculture production, we also could do some material flow analysis. So this is a quantitative diagram, but we could also use data to quantify each of the flow and the stock. So based on this, we could quantify the water, carbon, and the nitrogen, phosphorus, and impacts of the entire agricultural process. And this example showing the nitrogen flow of the entire food system. We could see there will be some flows from biological nitrogen fixation, which takes nitrogen from the air to fixed by crops, especially such as the soybeans or others. Yeah, and then this nitrogen fixed by crops will goes to feed for animals, and we may also goes to household factories for food processing and consumption. And those during those flow within those flows there are nitrogen embedded in the products, or nitrogen emissions from those processes. So this is also very straightforward example of nitrogen flow analysis. So after that, we could think about what's limitations of material flow analysis, because we could from that we could know the flows and stocks and the processes of food system, but what's the quality of the flows, right? Yeah, we could say, yeah, we have a very large amount of, we have a very abundant supply of vegetables that could support the nutrition requirements of every one of us, but what's the quality of the vegetable? Yeah, it is fresh or not? It is nutritious or not? So those are the omitted parts of the material flow analysis. Yeah, and then the other one is decision making. Yeah, how material flow analysis could enable policy actions or industry transitions and the others. Yeah, because we have like information, many of the informations we could get from material flow analysis, but how those informations could be applied to real practice. this is also something we need to consider about. So based on that, we could say material photolysis is a careful balancing of the stocks and the flows of a set of processes within a well-defined system boundary. But we could also use this information for many purposes such as the planning, optimization, and the forecasting, and the developing indicators. Yeah, but also those are also based on theoretical analysis, but not so close to decision making or actions. And these informations, those knowledge need some other tools or methods to to investigate. So since we talked about the oh, okay, sorry, there's another one. So material flows impact are not covered in the material analysis, material flow analysis. For example, we only know how much food is wasted, or how much nitrogen is flowed from food production to processing, but we don't know the impact of those food waste and also nitrogen flows. So if we want to solve this problem, we need to introduce life cycle assessment. So life cycle assessment is beyond material flow analysis by including materials impacts. For example, about half of the vegetable produced in China is wasted. So during the food waste, there will be some energy use or carbon emissions during the food production and supply that goes in vain because of the food waste. And there is also some energy consumption and the carbon emissions during the waste disposal because like the discarded vegetables or leftovers that goes to landfill. And during that process, there will also large amount of carbon emissions. So life cycle assessment is trying to solve the problem of the materials impact. So we can just make a guess. So life cycle from life cycle perspective, how much water is needed to produce a serving of potato chips? So you can make a guess. A serving of potato chips is like 4 ounces or like half pounds or like a quarter of kilogram. So that amount is not much, but how much water is needed in producing a serving potato chips? So to answer this question, we need to know the processes of producing potato chips, right? And what uh, what are the processes? What are the processes that requires water input, right? For example, we need to clean the potatoes before cooking the chips, right? And we also need to clean the facilities, and we also need water to produce raw potatoes, right? And especially if we want to keep the potato fresh during distribution, we also need to keep the potato in the perfect moisture level. So those processes also need water. So a plate of a serving of potato chips need like more than 100 liters of water. So this is quite a lot. So we could say there's some bottled water or bottle is only like half a liter, right? So that means to produce a serving of potato chips, we need to like more than 200 bottles of water, right? So this is quite a lot from if we look at the impact from the life cycle perspective. Another example is to compare the emissions on the gasoline vehicle and the electrical vehicle. Yeah. So normally we will say there is a less emissions from an electrical vehicle because no gas is burned or no coal, no diesel is burned during the um, vehicle use. Yeah, but if we look at the emissions from a life cycle perspective, we could say, yeah, for electrical vehicles, there is an actually very low zero emissions from pump to wells. That means um, no gasoline consumption. But however, if we look at the emissions from the well to pump stage, that means the stage to producing energy, or producing like energy, producing gasoline or producing electricity. And during that process, there is more emissions, especially for this kind of choices vehicle. The life cycle emission is much larger than gasoline vehicle, right? So we can't simply say that electrical vehicle is more low, has lower carbon emission than traditional vehicles or gasoline vehicles, right? Because um, for um, for every product or every process, we need to look at the impact from a life cycle perspective, especially for battery production of the electric vehicle, that is also very carbon intensive. So if we include the manufacturing process of vehicles, the that is still interesting to compare the emissions of the manufacturing process. So the life cycle impact of products, we need to know the inputs of the product system, and also we also need to know the output of the product system. So during the production system, we need to consider the entire, or at least most of the life cycle processes, for example, from material extraction to transport to processing to manufacturing to product use and also waste management. We could include all of them, or at least the majority of them, because all the processes are very important. So the life cycle impact means a change to the environment. For example, we want to know the carbon emissions of our product or our process. We are looking at the changes of the atmosphere in terms of carbon emission. So this is the environmental impact we are trying to look at. So the purpose of the LCA is to avoid the burden shifting. For example, when we comparing gasoline vehicle with electrical vehicle, we are not going to shift the burden to the emission burden to the pump to well, right? To those processes, because we're shifting burden, the environment burden from one process to another one. So the purpose, the life cycle assessment is trying to avoid those things. Yeah. So this is most commonly mentioned the steps of the life cycle assessment. And there are 4 steps we need to bear in mind, because if you claim you are a life cycle assessment person, you definitely need to know what's the 4 components or 4 steps. The first step is the goal and the scope definition. We need to know which product we are going to look at, which process we are going to look at, and the scope definition of it. Yeah, how many processes we include? Do we include resource extraction, or we not include it? Yeah. So this is the scope. The first one is the scope, and the second one is the inventory analysis. So for each of the process, we need to the input and output of the process, and then we also look at the various resource needed. For example, for resource extraction, like metal ore extraction, we need energy, we need facilities, we need water, we need many other materials. So all the materials input is needed to be considered. And also the output is also need to be considered. So this is the second step, inventory analysis. So the third step is the life cycle impact assessment. So what's the meaning that if we already know the resource input or the emission from the process, and what's the meaning of those emissions? What's the meaning of the emissions to human health or to the biodiversity loss or to the natural resources? So this is the third step. The last step is the most important one, namely interpretation. So with the data records from the analysis or from the data results from the assessment, we need to know what's the meaning of this. What's this? What kind of decisions could be made? What kind of policies could be discussed, and what kind of transitions could be made based on those data analysis. So this is four parts or four steps of LCA: scope definition, inventory analysis, impact assessment, and interpretation. So if we want to go deep in for each of the step, there are many items we need to bear in mind. For example, there are also some elements or some factors we need to consider to define the goal or the scope. So we need to first be clear the intended application of the analysis and the reasons to carry out this study. For example, why electrical vehicle is important because it's a new trend and it's deemed to be have lower carbon emissions than gasoline vehicles. So we need to analyze the life cycle assessment, life cycle emissions of it to say if it is really that low carbon than traditional vehicle, right? So we also need to be clear the intended audience. We are talking to the vehicle producers. I mean the entrepreneurs, or are we trying to talk to the investors or talk to the policymakers or others? Yeah. So those are some elements of the goal definition. So based on that, we could brainstorm the goal of studying milk alternatives. What should be included in the goal of studying milk, different kind of milk. For example, we could say here some almond braisé and the silk or rice stream. There are many other different kind of milks made from different materials. For example, the cow milk or nut milk or soy milk. Yeah. So we need to consider the intended application. We will build up the database for different milk products, and the reasons why carrying out the study, because milk is a common food for our daily life, and the consumption amount could be like many gigatons or more per day or per year. Yeah, and this is a large amount, and the emissions could be take about like 10% or 20% of the entire food system, which is a large amount. And the intended audience could be consumers, for them to pick the products with lower emissions, or for the audience could be also producers to improve the process or adopt more cleaner technology. Yeah, and the second step is to besides the definition of the scope, we need to define the functional unit. So functional unit is quantified performance of product system for use as a reference unit. For example, a serving of a serving of fried chips or potato chips. Yeah, we talked before. Yeah, or a cup of milk or a bottle of milk, uh, or others. Yeah, or like a episode of a TV series. Yeah, or anything others is that has a function to our daily life, or we could make use of. Uh, the basic unit that we can make use of is a functional unit. So when we talking about the emission intensities, we are usually uh, standardize the total amount according to the functional unit, right? So we could also brainstorm the functional unit for different kinds of milk. Yeah, we could usually say a liter of milk, or um, a thousand kilocalories of milk, or uh, 100 grams of protein within the milk, right? So those are many different categories, sorry, functional units, uh, based on our purpose. Yeah. So then we need to figure out the product system. So the product system is a collection of unit process with elementary flows. So for example, for to produce the milk, what kind of process units do we have? Yeah, we need to rearing the cow, milk cow, and also we need feed to rearing the cow, and we after the raw milk is harvested, we need to process the milk, or and also kill the batteries, and to um, to fill the milk into bottles and other processes. Yeah, you can also brainstorm by yourselves, and also if you want, you can type in the chat box. So as we keep going, and we could show some typical milk products, the product system of the typical milk products. For example, almond milk. We need almond agriculture, and in shell to track to processor for the almond, and for each processor we need many inputs and also output. For example, during the almond agriculture, we need water, diesel, gasoline, electricity, fertilizers, and also additives to the agriculture process. Yeah, and for soy milk and dairy milk, there are also many processes, meaning that uh, how the product is processed from the very beginning to the final products. So this is the product system of each one. So maybe also not many of us are experts in milk or dairy industry. So when you have limited knowledge about this, the what's the method to solve this problem? Yeah, remember we talked about the framework thinking and system thinking in the former part of the course, and we also need to draw some sketches to define the product system, and then yeah we need to do some field survey, or we ask the secretaries, we could ask the experts, do literature review, or do round table discussion with our colleagues and peers. So those are the method to define or finalize the product system. Uh, so um, so combining all of this, we could define the system boundary to say what is included and what is not included. and the processes could be, simplified from extraction to to the system boundary to the product system. And then we also need to mention what kind of environmental impacts or sustainability related indicators we are caring about. So the next step is the life cycle inventory. This is we mentioned before from the milk industry, the dairy industry, where for each of the process, for example, the almond production, we need to figure out the inputs and also the outputs. So the next step is to connect the life cycle inventory data. So when we have many data sources, for example, primary data from field survey or monitoring, and also we could use secondary data from literature or from dedicated databases. So this is an example of the product system of different food. For example, we have the agriculture input and for the crop production, and also have some fodder, straw, and the other feed input to the livestock and poultry. Yeah, and this is like a very simplified product system for the different food systems. But from this, here also needs some activity data or parameters that is needed to conduct the life cycle assessment for different food categories. And here is the results to for the the final results for the life cycle assessment. So we could also do some indicator analysis. For example, the land use emission intensity, meaning the emissions per unit of land use, and also the emissions per calorie, and those are the result comparisons between different food categories. So this is example of how to define the product system on the research objective, and then how to analyze the data. So the next step is besides the life cycle inventory and also the indicator analysis. The next step is to conduct the impact analysis. Meaning, so this is very important because we need to know what's the impact, what's the final effects of CO2 emissions or water depletion. So we have some midpoints as impact and also endpoint impacts. For midpoint impacts, we could analyze the global warming potential, or acidification potential, or water eutrophication potential due to the emissions or resource use. And for the endpoint, we only consider the human health, ecosystem damage, and natural resources. So those are the three major indicators for the endpoints. But all these are based on the life cycle inventory, and this is the foundation of the subsequent analysis. Okay, so this is also a definition of the midpoint and the endpoint, analysis, but has many more details in terms of inventory, like particulate matter, and also impact category, and also endpoints categories. So this is like a detailed version of the of this slide. Yeah, from inventory to midpoint impact to endpoint impact. So the next step of the life cycle assessment is interpretation, and this is also the most important part because this is the meaningless of our study and the key message we want to convey to do such not huge amount of inventory analysis and also midpoint and endpoint analysis. So when we could break down the interpretation into what's the main mental flows and what's the main impacts and how sensitive are the results and assumptions and what can be generalized. So what processes has natural emission or impact, and what processes could be improved or optimized. So those are the interpretation we need to do for the next step of the life cycle assessment. And actually, this is objective of our research to have some implications for the um, stakeholders. Yeah, for example, there are some generalizable findings from the previous studies in terms of milk or dairy industry. Then we could say, soy and oat milk tend to perform better than dairy. Yeah, so this is a comparison of the impacts from different kinds of milk, and then we could also have some implications from this from these findings. And there are also further interpretation of the results if we have some enough data from the inventory and impacts. For example, for the milk storage, we prefer shelf-stable milks that could be stored for a longer time and with no with a little has a little requirement for the cold chain or fridge use. Yeah, because the milk is shelf stable. But however, to produce shelf stable milk, we need ultra high temperature to kill the batteries. Yeah, in the processing phase. So, we need to consider all of these processes, the impacts from all the processes to say which one is really better from the life cycle perspective. The other example is urban agriculture, because we know urban agriculture could reduce food loss and waste, and could reduce food miles because this is locally produced. But actually, compared to conventional agriculture, urban agriculture have extra cost. For example, on the roofs, we need to build up the facilities, right? And then there is also some benefits to reduce emissions. For example, to reduce the food miles. So what's the main what's the final what's the final the net impact? So what the final impact? It's the larger or smaller. So this need need data support from life cycle assessment. So this is results from the previous research on nature cities. We could say the results is urban agriculture, the emission from urban agriculture is much larger than conventional agriculture, yeah, due to its lower technology and also extra facilities used. And this is another example showing the showing the environmental impacts of biodiesel and other and the traditional diesels. Yeah. Okay. Yeah. So yeah, I will finish very soon. So this is another example of the life cycle assessment, and this is a very general topic about the social life cycle assessment, because when we introducing material flow analysis, we could say we found that material flow analysis can't evaluate the quality of the flows. For example, the vegetable is fresh or not, or nutritious or not, and for life cycle assessment, this is there is a similar drawback that is social part of the social indicators or aspect of the system. So we need to consider like a social capital or the economic process or the enterprise behaviors of the processes. So those could be enabled by conducting social life cycle assessment, but no details here. But I will show you the very quick show you an example very quickly about the evaluation of the nutrition status. So here is like a health index by evaluating the scores of the food consumption behaviors. For example, how much food varieties were consumed each day, and how much fruits or dairy were consumed each day. And based on the amount of the consumption, a score could be evaluated, and then some of all of them, we could say in China, the full score is 100, and for most regions, the total score is less than 60. So actually, we could see the nutrition status of the food consumption is very low, right? Because it's got less than 6% of the full score. Okay, so we'll wrap up all the lecture by mentioning a few questions for you. So the first one is what's the role of framework and system thinking in food system analysis? How those analysis could benefit food system transformation or food system sustainability. And the second one is how quantitative and quantitative analysis could be integrated to avoid biased understanding of the system. Yeah, because when we reinforcing one action or one policy, there will be some unintended effects of that policy. So how to avoid that unintended effects, or how to avoid bias understanding for the system? And because we normally say vegetarian is more has lower carbon emissions, and meat eaters have more carbon emissions. But is this the truth? I'm not sure. Yeah, but we need to combine those methods. And then the third one is what are the key procedures of conducting MFA and LCA? Yeah, I have a few examples showing before, and maybe and you must have some general understanding of the procedures. But yeah, you could after that you could write down some sentences, some lines, and to help you to review and bear some of the key procedures in mind. Because yeah, we're becoming expert of this field. So okay, that's it. Yeah, and